All right, so hopefully you took the opportunity to finish this car dealership example, and we have the first one, the probability that a randomly chosen business's goods service, or, that's a union, has been in service less than 10 years. So we'll do less than 10 here. And this, remember, is a compound event. This is the probability of a goods service, and then plus the probability of less than 10 years of service. But because we're talking about a two-way table where there is dependence, we have to take out the thing that we have counted twice, the good service and the less than 10 years of service, because when we go to find the probability of good service, we're adding up all these values, and when, good service, we're adding up all these values, and then for less than 10 years of service, we're adding up all these values, and we will have counted this one right here twice, and that's the overlap one. That's the good service and less than 10 years of service that we have to take out. So our probability here is going to look like good service. There are 26 out of the 50 dealerships that had good service, plus the probability of being less than 10 years of service. That's 30 out of 50. And then we have to subtract out the 10 that we have counted in 2 times, the good service and the less than 10 years of service. So what we end up here is having 46 out of 50. And of course that would not be a simplified fraction. We have to simplify that. But I'm just going to go ahead and give it as a decimal. So as a decimal we have 46 divided by 50. And that gives us 0.92. So we have 0.92 as our probability here, and we can put that extra 0 on there just to continue to show 3 decimal points. Find the probability that a randomly chosen business that has been in service 10 years or less, or 10 years or more, is bad. Okay, well, I'm saying that I'm only choosing from those that have greater than or equal to 10 years of service. And I want to know the bad ones given that. So this is a conditional probability. So I'm choosing from those that have 10 or more years of service. There are only 20 that have 10 or more years of service, and the ones that are bad and 10 or more years of service, there are 4, the box of overlap. And so this gives me a 1 out of 5 chance. That is a common fraction, so that usually would be a perfectly acceptable answer. And then there's our decimal representation. Now our last one says find the probability that 2 randomly chosen businesses both have good service. So 2 randomly chosen good services. And so this is the probability that we choose a good one on the first go around times the probability that we choose a good one on the second one, given that we've already had a good one on the first one. So the probability of a good service, well, there's 26 out of 50. And then the next go around, we're down to only 49 to choose from, and only 25 of which have good service. So let's go ahead and get our scientific calculator out. I think that'll make my life a little bit easier here. So I have 26. Now let's clear this out. 26 times 25, and that equals, and now I'm going to divide that by, and I'm going to do 50 times 49. And that's showing me exactly what I have there, right? And that's going to give me, that's going to give me 13/49ths, and that would be my answer. So this would be 13/49ths, and that would be 0.265 approximately. So that would be my answer once again. And you see our probability there. And again, conditional probability matters because we don't have that first person to choose from when we choose the second one. All right, let's see. If 3 people are randomly chosen, what is the probability that all were born on Friday? Well, the probability that they were all born on Friday. This is a little different than that last birthday question that we asked. Remember the last birthday question that I asked, I said the probability that they're all born on the same day. Well, this time around, if I'm asking the probability that they're all born on Friday, Friday's already a given. So the probability that they're all born on Friday, these are independent events, and they don't affect one another in any way, shape, or form. So this is the probability of Friday on the first one, and then times the probability of the Friday on the second one. And whether you put in here that there's conditional or not, it doesn't matter because these Fridays are all simple independent events. So the probability of anyone being born on a Friday is 1 in 7 chance, and the probability of anyone being born on Friday is a 1 in 7 chance, and the probability of anybody being born on a Friday is a 1 in 7 chance. And so this is a 1 in 343rd chance. Now Triola usually leaves anything that's 1 over a number simply as the number. He doesn't usually change them to decimals, but a lot of other books will still do that as a decimal. So let's go ahead and clear this out and do 7 cubed, and you see what I mean, 7 cubed, and then that equals, and there's your 343, and then I'm going to take the reciprocal of that, so 1 over 343, and then I'll see what that equals. And so this is 0.002915, and so this would look like 0.00292, and that would be my approximate probability that they were all born on Friday. A very unlikely event. Remember that that Triola says an unusual event is less than 0.05, and that's one of his indicators, right? And that is definitely less than 0.05. This would be what I would call an extremely unusual event because we have less than a 1% chance of this occurring. And we see, we're going to see these again when we see hypothesis testing. We'll start seeing some of those probabilities pop up, and the idea of where we're unusual will be something that we predefine.